In this module, we're going to examine code contracts. Code contracts is a tool from Microsoft Research that integrates with Visual Studio in order to prove the correctness of our code. It includes a class library that gives us runtime contract checking and a compiler plugin that gives us static contract checking. So to get started, you want to go to research.microsoft.com/contracts and download code contracts and the documentation. Go ahead and save the documentation for later reference. And then you'll want to go into Visual Studio's Extension Manager and get the Code Contracts Editor extensions. Once you've done that, then you can go into your project properties and you can enable Perform Runtime Contract Checking and Perform Static Contract Checking. And then within your code you use the contract class to specify your assertions, your preconditions using the requires method, postconditions using ensures, and invariants using the invariant method. So far, I've done the first two setup steps. I've downloaded Code Contracts and installed it, and I've also installed the Visual Studio Editor extensions for Code Contracts. Now let's use Code Contracts to prove the linked list non-null example, but do it in a way that doesn't clutter up our code. First, I'm going to make sure that Code Contracts is working properly. So let me do a contract.assert for something that I know I can't prove. I'm going to assert that head is not null, just to see if everything's working. When I build, I don't get any errors or warnings. That's because I don't have Code Contracts turned on yet. So let me go into the solution, into the project properties, and I'll turn on Perform Static Contract Checking. I'll also increase this warning level from low to high. At the low warning level, it wouldn't report this problem. So now let me build. And the build succeeds, but Code Contracts are checked in the background after the build. When it's finished, we get this message. And then we'll get warnings for anything that it can't prove. So here it can't prove that head is not equal to null. So now I know that Code Contracts is working. Let's start to develop the solution. So the first thing that I want to do is append this to the end of the linked list. Let's just do the simplest thing and set head.next equal to new node. Now obviously this is incorrect, but I want to ensure that that head is not null before I make this assignment. Let's see if Code Contracts can prove that. So it builds, and then after the build, Code Contracts completes, but it checked 0 assertions. There was nothing in this code for it to prove. So I could write contract.assert the head is not equal to null. And as we've seen before, it's unable to prove that. And so we get a warning. But I don't want to clutter my code up with these assertions every time I want to use a reference. So let me go into the project properties, and I'm going to turn on implicit non-null obligations. This is going to implicitly put that assertion before this assignment. Now let's build, and when Code Contracts completes, we've got a warning. So I'm possibly calling a method on a null reference. Excellent. So now let's make sure that head is not null. So if head is null, Then I say head is equal to new node, else I'm going to append it to head. Let's build that. And now Code Contracts is able to approve all of the assertions that it can find. So I know that I'm not going to be referencing a null pointer, but this obviously is not a correct implementation of append. In order to correctly append to a linked list, I want to make sure that I am not replacing a non-null pointer. So here, I'm going to do contract.assert that head is equal to null. That way, I'm not replacing a non-null pointer here. And here, contract.assert that head.next is equal to null. So that I'm not replacing a pointer here. Let's check that one. Code contracts completes, and it's unable to prove this assertion. So we know that we need to actually scan through until we find the end of the list. So let's create node seek. Start that out at head. And then while seek is not null, seek equals head.next, and then we're going to replace seek.next. Does this look right to you? Well, let's see what Code Contracts thinks. Let's build it. And we find that we've got a couple of warnings. This assertion is unproven, and I'm also calling a method on a null reference, seek. So that means that it can actually prove by the time I get here that seek is equal to null. And that's because I made a mistake right here. In my while loop, I'm exiting the loop exactly when seek is equal to null. That's not what I wanted. I meant seek.next is not null. Now let's try that. And I get a warning. I'm possibly calling a method on a null reference, seek. Interesting. So here I've said seek is equal to the head, so I know that because of this else, seek is not going to be null. But it's thinking that seek could be null. It must be the next time I come through this while. So it can't prove at the end of this loop that seek is not null. Oh, I see the problem. I meant to say seek equals seek.next. Now here I just checked seek.next is not null, so I know that seek will not be null by the time I finish this while loop. So let's see if that satisfies Code Contracts. And it does. So now it's able to properly confirm all of my assertions. I'm not going to be referencing any null pointers, and I'm not going to be replacing any non-null pointers. Now there's one other assertion that I want to make on this code. I want to make sure that by the time it's finished, that the list is not empty. So I'm going to say contract.ensures head not equal to null. Now you might think that this should belong at the end of the method, because I can only ensure that head is not null after I've reached the end. But in fact, all of the preconditions and postconditions go at the front of the method. That's because these are decorations on the method itself, not part of its implementation. I want the caller to be able to use this ensures, this postcondition, in its further proofs. So that's why I'm not just using an assertion, but rather ensures. Let's see if I can prove that head is not null. Code contracts comes back and tells us that no, we can't prove that head is not null. And it's saying that if we go through this path here, then there's a possibility that we'll end up with a null pointer in head. So let's examine this path. We're setting head equal to new node. So there's nothing in here that is saying that new node is not null. If I call append on an empty list and pass in a null pointer, then that list will still be empty by the time I leave. So that means I need to strengthen my contract. I need to add a precondition requires new node not equal to null. So now the compiler says that everything is all right. It's able to check all those assertions. The ones inside of my implementation, the ones that were inferred by using a reference, and then the preconditions and postconditions that I added to my contract. And so code contracts is able to do the same kind of proof that we did by hand, but do it in a way that doesn't clutter up our code.